Welcome back. Let's begin our discussion on a brand new topic, and that will be evaluating fractions. And this will be the first of maybe 3 or 4 videos on this topic. So without further delay, let's get started. If W equals 1/8, what is W raised to the power 2/3? Okay. So when you say W raised to the power 2/3, that's essentially cube root of W squared. Remember, when you have a fractional value like this, the denominator always becomes the root aspect and the numerator becomes the square aspect, okay? Or cube, whatever be it, okay? So essentially what we are going to do is substitute W with 1/8 and cube it, so take a cube root of it and then square it, okay? This is essentially 1/2 squared. That's 1/4. Why? Because cube root of 1/8 is same as 1/2 cube, right? Of cube root, right? And cube root of 1 is just 1. And cube root of 2 cube is the 3's cancel out, so which leaves you with just 1/2. And that's how I got this 1/2 here. Okay. And it's a very simple problem, but you can expect this sort of problem on a SAT exam, right? The second problem is very, very simple. Given P/6 is an integer, which of the following is a possible value of P? We say a number is integer when it is a whole number, that is, it doesn't carry any decimal values, right? We know right away the answer is 0. For those of you that are wondering still how it's 0, well, substitute 2 in place of P, that'll give you a decimal value, right? So that cannot be an integer. What if you substitute 4? Still, it's not a whole number. What if you substitute 3? No, still not a whole number. What if you substitute 16? No, still not a whole number. Whereas when you substitute 0, 0 divided by any number will give you 0, and 0 is an integer. So the answer is choice A. All right, let's get going. Simplify the following fraction: a squared over b divided by a over b. If you notice in the question, there's 2 types of lines, right? The numerator has 2 components. The denominator has 2 components. The numerator and the denominator are separated by a larger line, right? That's very important that when you write, you make that distinction, okay? So how do we solve it? Here's how I do it. You may disagree with me, you may have your own way, but this is for people that are struggling with the concept. I always retain the numerator as it is, don't make any change to it, and multiply it by the denominator. And when I do, I flip the terms. In other words, I'm going to bring the b to the numerator and a to the denominator. Okay, so when I multiply it, instead of multiplying the a over b, which you cannot do it that way, and so essentially it's b over a. B and b cancels out. A and a squared cancels out, with resulting in a as the answer. So it's choice 5. Right? Let's go ahead and solve the second problem. Compared to the problem we just solved, this problem is rather complex on one side and simpler on the other side, right? When you have such a situation, you're better off solving one side completely to the lowest form possible and then equate it to the term on the other side. It makes the problem way, way simple. So here's how we're going to do it. So x minus 2, 4 squared, 16 over x squared minus, I'm going to write the 4 as 2 squared over 2. Why did I do that? Because a squared minus b squared equals a minus b times a plus b. Okay, so let's write it even further as x minus 2 over 16 over x, I'm going to write this line longer, x minus 2 times x plus 2 over 2. Okay, As always, let's retain the numerator as it is. Multiply by, you flip the term, so the 2 comes to the top, the x minus 2, and x plus 2 comes to the bottom. So the x minus 2 cancels out. This cancels out, leading to an 8. So on one side, we have 1 over 8 times x plus 2, which is same as 1 over 8x plus 16. Now we equated to the term on the other side. So this essentially is 1 equals 8x plus 16. If you subtract 16 on both sides, we end up with negative 15 equals 8x, implies x equals negative 15 over 8. That's the answer. Right? Very simple. Let's keep going. 4 over 4 times x power 5 y cubed times z over 12 x cubed y power 6 times z squared. Okay, 4 and 12, when you divide, you're going to get 1 over 3. And when you have x power 5 divided by x cubed, I'm showing you the proper procedure this time around. In the future, we can use shortcuts, but let's do it the proper way the first time. Okay, when you divide this way, this is essentially writing it as x power 5 times x power negative 3, right? We are bringing the denominator to the numerator. Okay, so we have to assign a negative value. This is same as x power a times x power minus b is same as x times a to the minus b. So that's essentially x power 5 minus 3 is x squared. So that's x squared. Y cubed divided by y power 6 is y cubed times y power negative 6. So again, y power 3 minus 6 is y to the negative 3. So y to the negative 3. Z power z squared is z times z power negative 2. So 1 minus 2, z to the negative 1. So you can leave it as it is if this was a descriptive question. Whereas if it is a multiple choice, it is highly unlikely they would have had this as an answer choice. I'm assuming you could also have this as an answer choice. You can leave the positive exponent in the numerator and bring the 2 negative exponents to the denominator. That'll be y cubed and z. That's it. Okay. Very simple, isn't it? Let's go to the next problem. Again, in this problem, you have 2 components, one component on the left side, one on the right side. The right side looked rather complex compared to the left side. So let's go ahead and simplify the right side first and then equate it to the term on the left side. Then we will be able to get R in terms of S. Okay, so 1 over 6 plus 1 minus 3S over 4R. What's the common factor in the denominator? That will be 24R, right? So 6 times 4R times 1, so the numerator will be 4R plus 4R times 6 will give you 24R. So 6 times 1 minus 3S. So that will be 4R plus 6 minus 18S over 24R, right? You can also do one thing is you can take 2 out of here, which will give you 2R plus 3 minus 9S divided by 24R, right? That will be 12R. So essentially this translates to 2R plus 3 minus 9S by 12R, right? That's equal to 11 plus S by 12R. Because the 2 denominators are equal, the numerators should be equal. So 11 plus S equals 2R plus 3 minus 9S, right? So we want R in terms of S. So let's retain the R on this side and bring everything else to the other side. So it's 11 minus 3, right? Plus S plus 9S, right? So that'll be 8 plus 10S, right? Equals 2R. If you take 2 on this side, then it'll be 4 plus 5s, right, equals 2r, 2 cancels out, so r equals 4 plus 5s. Isn't that simple? All right, let's keep going. So this problem is very simple. Only way you make it difficult is if you retain the 0.5 as it is, okay? There's an easier way to do it. So essentially, you can write the 0.5 as 1 over half, or 1/2, sorry, and you divide this whole thing by 1 over x plus 4. When you have a problem like this, it's better to simplify one term completely before you use the second term. So in other words, it's x minus 4. I'm going to assign an imaginary value of 1 and divide the whole thing by half. You see that this is the numerator, this is the denominator, right? So by having the 1, you can use the technique that you're familiar with, right? So that's essentially x minus 4 power 1 divided by 1 times 2 over 1. So that's 2x minus 8, right? That is only this portion, right? We still have to divide this by 1 over x plus 4. So I'm again going to assign a temporary value of 1 and divide the whole thing by 1 over x plus 4. So that means 2x minus 8, I'm going to write it here, 2x minus 8 over 1 times x plus 4 over 1, right? So that's essentially, if you use the FOIL method we learned before, then we get 2x squared plus 8x minus 8x minus 32. These two cancel out, leave you with 2x squared minus 32. The takeaway here is assigning this imaginary 1, you know, that retains the format that you're familiar with, okay? For some people, not having that format could cause trouble, which is why I'm consistently retaining that format, so it makes the problem very simple. All right, let's go ahead and solve the second problem. You're given this expression, that expression is equal to a over b. What's the value of a plus b? Okay. All right, let's first simplify the term on the left side. Okay, it looks huge, right? And even within that, you have to solve it in 2 steps. Okay, let's take first the numerator and solve it. Okay, so that'll be, what's the common factor between 4, 3, and 5? Well, I think it's 60. Okay, there's nothing common, so you have to multiply all 3 of them. So 4 times 3 times 5 is 60. So essentially that'll be 15 plus 20 minus 12. That's 23 over 60, right? This is only the numerator, right? Let's go ahead and solve the denominator. So again, 6 is a common factor. So it'll be 3 minus 1 plus 6. So that'll be 8 over 6, right? So let's go ahead and even reduce the 8 over 6 even further. So that'll be what, 2 times 4 over 3, right? Now we have it in a way that we're familiar with. So that'll be 23 over 60 times 3 over 4. So this is 20 times 23 over 80. Because the question says where a and b are both positive integers whose greatest common factor is 1, we can say that, okay? And we also know this whole expression is equal to a over b. Because a and b have a greatest common factor of 1, we can simply say a equals 23, b equals 80. That means a plus b equals 23 plus 80 equals 80 plus 23 is 113, is it? Yeah. That's it. All right. Well, if you learned something in this video, please share the video with your friends and family members, and please subscribe to my channel. And thank you for watching. I'll see you with another video on the topic of evaluating fractions. All right, so stay tuned.